Go on. Okay, so
Is it recording?
yes, it's recording.
Oh, okay.
So on, I don't even remember when we did this. Monday was it?
Mm-hmm.
On Monday we did that popcorn activity. So basically, you were given a piece of paper. You were supposed to cut out squares, and the squares were x values. Well, they weren't x values. They weren't variable. I actually told you which centimeters to cut them off. But we'll call the squares x variables. We're going to actually work out from this piece of paper what's the maximum volume we can form from this box. So before we begin, we actually need to get an equation for volume. So we want to find an equation for volume. For volume. So looking at this box, when you fold it up, it should actually look like a tray or an open box. So what would this height be? This part
X.
here. X. What would this part be here then?
21 minus 2x.
Yeah, 21 minus
2x.
2x. And what would this one be here then?
30 minus 2x.
No, we're not rounding it off. So 29.8 minus 2x. Don't round it off. I know, rounding it off would make it easier to calculate, but we won't round it off. We'll be exact. Alright, so when we fold up those sides, that's our box. So what's our equation for our volume then? Our volume equation, what would it be?
Length times breadth.
All those add.
Yeah, all
Oh,
those sides
yeah.
multiplied. So it's going to be x times 21 minus 2x times 29.8 minus 2x. That's not very neat. So what we're going to do is we're going to try and see if we can expand and collect like terms. So 21 times 29.8.
Big.
Nope, don't have the calculator. Yes, I do. Okay. So 21 times 29.8 is 625.8 minus 2 times 21, which is 42x minus 29.8 times 2, 59.6 plus 4x squared. So that's expanding. The next part is collecting like terms. So we have two like terms, it's these two. So the minus 42 and the 58.6. So we can just add, collect those two terms. Did I make a mistake? No, no. So I've just expanded, then I've collected like terms, so that's the neater version. But what we're going to do here is we're going to times x to all these terms so that we have just one equation. So this is our one equation. And now that we have an equation for volume, what do you reckon the next step is if we're solving for max volume? What do we do next? Do you reckon?
Differentiate.
Yeah, differentiate. So using the equation for volume, you're going to differentiate. Okay, so differentiating this, dv dx. This is just going to be 625.8 minus 2 times 101.6 plus 8 times, well that's x cubed, so 8 times x squared. So 625.8.
It's not even 12. Not even 12, that's
Yeah,
right.
it's 12. It was 12 because I forgot to put the cubic before. So this is
Won't there still be an X? at the end?
200.
Will there still be an X at the end
Yeah, there'll be x squared.
of the 100
This one.
that one?
Yeah.
So what we have, just making it neater now. So our final derivative is actually a quadratic equation. So after you derived it, what's the next step? Because we're finding max volume, so what's the next step?
Finding x.
Solve for x. So after you derive it, we're going to solve for x by substituting dv dx as 0.
Yeah.
So we have a quadratic equation. So what's the best way of solving this quadratic
Quadratic
equation?
formula.
Yes, quadratic formula. The best way is just to use the quadratic formula.
Is it better in the spreadsheet? We still have a spreadsheet, right?
Yeah, I have one on my desk. I'll just check. Okay, so I'm substituting b for 203.2 plus minus, and b squared is 203.2 all squared minus 4 times a, and times by c, which is just 12. Nope, I did this wrong. Okay, it is a quadratic equation, but I need to rearrange it. So rearranging this, it's 12x squared minus 203.2x plus 625.8. So this is, a is going to be 12, b is negative 203.2, and c is 625.8. Now you can substitute that into the quadratic equation.
Oh.
That's captured, so
Well,
yeah, it's going to be a bit messy.
that is huge, man.
Is it?
Yeah, it's alright.
Okay, substituting your a's, your b's, and your c's into the quadratic equation, we get this. All over 2 times 12. So I'll leave. No, I don't have a calculator. Phil, can I borrow yours? Thank you. Alright, so we'll leave this as is. Leave the 203.2 as is, plus minus, and then we're going to find the answer to that. Two all squared minus 4 times 12 times 624.8. So 11,251.84 all over 24. So we'll see what the two solutions are. 203. Nope. Has anyone actually done this? No?
I got 17.8
You got 17.
plus x. Yeah, 17.8.
See. Well, I've got 12. Yeah, I've got 12.88. So 6.
Is that for minus though, or?
That's plus.
Minus your
Or right?
4.046.
Which one did you get for minus?
4.046.
Okay, we'll see what I
It's
get.
the 4 one that works.
Yeah, it's the 4. It should be your final answer. Okay, so 4.046.
046. 887881.
Okay, so that's your two solutions. So because we actually have a quadratic equation as our derivative, we're going to have two turning points. Because our originals are cubic, so being a cubic, and when you derive it as a quadratic, there's two solutions. Two solutions indicates two turning points. So we're going to determine which one of these are your max and which one's your min. So there's two ways of doing it. You can use a table of values, or you can move on to second derivative. It's up to you which one you would prefer. Table of values or second derivative? Second? Alright, we'll do second derivative then. So your first derivative was 625.8 minus 203.2x plus 12x squared. So your second derivative will be, so that is 0. That is 0 because it's constant. It's 203.2 plus 24x. So to prove that, to prove concavity or to prove maximum and minimum points using second derivative, we substitute. So we sub. I want to round off now because it's really messy. So sub 12.9 into this derivative squared. Is it negative? Or is it positive for this one? Positive? Or just check what the value is. So I'm substituting x equals 12.9 into this equation.
I know what it is.
And we can see it's a positive 106.4. So positive value is concave up, so concave up has a minimum turning point. So what that tells us, so in terms of the practical application, what that tells us is if your squares are 2.9 by 2.9, you'll have the minimum volume. So I think someone did 10 by 10. Philip, did you do 10 by 10?
Yeah.
Yeah, 10 by 10 was tiny, wasn't it? You can get even smaller. 12.9 by 12.9 would be the smallest. So if you ever did 12.9 by 12.9 squares, it should be absolutely tiny.
Nothing can get in.
Nothing can get in, so you can't fit any popcorn in. You barely could fit any popcorn in for 10 by 10. So that's our minimum. So obviously,
Is it
because,
even testing at this point?
huh? We're not going to test it. I already gave you the practical activity. You already tested during your practical activity.
Should've done that.
Whether or not you ate the popcorn or test it, that's up to you. But yes, 12.9 is the smallest volume you can get from those squares. So now the biggest one, I'm assuming, is going to be that 4. So we'll test the second one. We still have the same second derivative, so that doesn't change. The only thing that changes is we're going to substitute instead. X equals, just do 4. And because it's a maximum turning point, what do you reckon we would get? A positive or a negative answer? Positive or negative?
Negative, sir.
Negative. So we get a negative 107.2. Negative is concave down, which gives you a maximum turning point. We're not done just yet. Okay, so we know that maximum occurs. So max occurs when x equals, is it x equals 4? So that's the maximum volume. So volume is, what would volume be equal to? What do we do to the 4? Where do we substitute x equals 4 into?
The original
The original.
equation.
Okay, so we want to work out what the volume is. So we just substitute for every x value, 4 4. Screw. Substituting this in, you should get an answer. Did it, Tom, you finished? What was your final answer?
1,133.72.
1,133.72 centimetres.
That would use the 4.046.
Oh, it doesn't matter. Similar, so something similar to this then. Okay, so that should be, that's how you do maximum and minimum problems with practical application. So as you're taking the notes down, we actually are going to do, I don't know how confident you feel with this topic. We could move on to the next exercise, or we could do questions.